Assalamualaikum warahmatullahi wabarakatuh, and good day to my panel. My name is NABIHA BINTI NIZAM, and today I would like to present my final project titled Effect of Rainfall on Paddy Cultivation using Satellite-Based Vegetation and Geographically Weighted Regression (GWR). This study was conducted under supervision Dr. Rahayu binti Haruna Rashid. This study focused on how rainfall influenced the health of paddy cultivation using remote sensing data Sentinel-2 and spatial analysis through GWR. So, next we will move to the abstract. We will start this presentation with abstract. Paddy is the main food crop in Malaysia. However, it is highly sensitive with water, especially with rainfall. Farmers rely on the right amount of water for good analysis. Paddy agriculture is significantly impacted by climate change. In Malaysia, rice and paddy are considered staple foods. The cultivation of rice paddies in Malaysia, like other regions of the world, is very susceptible to weather variations and harsh circumstances like floodings and drought. This research explores the application of remote sensing and geographic information system (GIS) in evaluating the healthiness of paddy cultivation in northern region Malaysia. Changing weather patterns and rising agriculture needs provide increasing difficulties for paddy farming methods such as irrigate fields, drought paddy and floods paddy. Others, geographical information system and remote sensing are widely employed in planning, land change assessment and field usage. Remote sensing offers a tool to identify the healthiness of vegetation over large spatial extents and multiple temporal scales. The result of this study will enable well-informed decision-making for sustainable agricultural management by offering crucial insight into the temporal and geographical changes in paddy cultivation impact by weather conditions. The aim of this study is to study the effect of rainfall on paddy cultivation between 2018 and 2022 in northern peninsular Malaysia using GWR and satellite image. So, for the objective, there is 3 objectives of this study. The first one is to identify paddy healthiness using Normalized Difference Vegetation Index (NDVI) and Enhanced Vegetation Index, which is EVI. So the second one is to estimate rainfall parameter using IDW method. So the last one is to determine the relationship between paddy healthiness and rainfall parameter using Geographically Weighted Regression (GWR). So, next is problem statement. As you know, Malaysia's paddy farming is vulnerable due to the changes in rainfall patterns. As rice is water dependent, droughts and floods both cause serious damage on paddy cultivation. These weather challenges driven by climate change raise concerns about food security, sustainable of farming practice. Without proper monitoring systems, farmers struggle to make data-driven decisions. That's why this study used satellite-based tools and GIS techniques to improve decision-making by mapping rainfall effects more accurately and locally. So, we will move to the methodology. So, the first one is planning. The study area are in Kedah, Penang and Perlis, which is it is a major paddy farming in northern area Malaysia. So for the second one is data acquisition. Sentinel-2 satellite image has been used to derive NDVI and EVI for the years of 2018 and 2022. For the rainfall data was obtained from Met Malaysia. For the phase 3 is data processing. Satellite image have been corrected. There is 3 corrections that have been derived, which is radiometric correction, geometric correction, and atmospheric correction. Based on the three corrections, I have derived the NDVI and EVI. NDVI and EVI values have been calculated to assess the vegetation healthiness. For your information, I've been using Google Earth Engine to produce this output. I've been using Google Earth Engine to get my satellite image and to process NDVI and EVI for assess vegetation health. After I process the NDVI and EVI, I will export to ArcMap, which is to come out with the final output, which is map of NDVI and EVI healthiness. So the rainfall data from Map Malaysia, I will do data standardization since I've been getting the CSV file. After that, I will use IDW, which is inverse distance weighted, which is spatial interpolation method in ArcMap tools. I've been using inverse distance weighted to estimate the rainfall patterns. The rainfall patterns for 2018 and 2022 are be using 42 stations in Peninsular Malaysia. After done using the IDW method, I will produce the final map, which is interpolation rainfall map. After that, the final output of NDVI, EVI and rainfall, I will use it to convert the raster to point. Before I convert the raster to point, I have derived the land use and land cover, which is I want to highlight the paddy crop in the study area. Land use and land cover have been derived to focusing the paddy crop in my study area. After that, I will layering the three parameter, which is NDVI, EVI and rainfall with the land use land cover paddy crop to convert from the raster to the point. Based on value, after convert the raster to the point, I will use it to determine the relationship between rainfall and paddy healthiness using GWR. After that, we will move to the phase 4, which is result. Based on the result, using the convert raster to point, I will use it to determine the relationship between paddy healthiness and rainfall using GWR. So, next is result and discussions. So, the first one is the result of the first objective. There is 4 maps, which is I have produced the NDVI and EVI map on 2018 and NDVI and EVI map for 2022. The NDVI and EVI maps show how healthy the vegetation is. Value closer to the green indicates the healthy paddy, while the red or yellow areas are stressed or unhealthy paddy. So, in 2018, there is many red and yellow areas were seen, especially in northern area part, indicating low crop health likely due to uneven rainfall. In 2022, there were more green zones which reflect better vegetation condition, possibly due to improved rainfall distribution or better water management. So, for the second result is rainfall map. The rainfall map shows how rainfall was spatially distributed. In 2018, rainfall was not evenly distributed. Some regions had lower rainfall, matching an unhealthy crop areas in the vegetation map. In 2022, rainfall was more evenly spread, and this corresponds with higher EVI values and greener vegetation. So the next map is the land use land cover classification map that has been used to highlight the paddy crop in my study area. So the last result is the result from GWR software. Let's now focus on the most important result, which is the comparison between GWR and OLS models. Based on this result, R square, which is coefficient of determination. For DGWR, R square is very high, which is 0.97 in 2018 and 0.9 in 2022. This result shows a strong spatial relationship between rainfall and paddy health. But for OLS, R square is very low, which is 0.04 and 0.01, which is showing almost no relationship. The next one is AIC, which is a key information criterion. So, for the AIC result, AIC is used to measure model quality, which is the lower and the better. GWR AIC is much lower than OLS, meaning GWR is more accurate and suitable model for this spatial anda. So based on this result, GWR is more effective than OLS. So, in conclusion, this study demonstrates the value of combining remote sensing with spatial analysis for sustainable agriculture. It provides a scientific approach to tackle the challenges of unpredictable weather patterns and help to ensure food security in Malaysia. I hope this research can contribute to better decision making in agriculture and support our local farmers in adapting to climate change. So, my last point is, I hope this research can contribute to better decision making in agriculture management and support our local farmer in adapting to climate change. So that's all from me. Thank you.